Let's talk about big data. Imagine a crime analyst who has access to millions of data points. Crime reports, social media feeds, surveillance footage, 911 calls, all feeding into a powerful computer system. Sounds like a crime-fighting dream. With big data, we could predict crime hotspots, deploy officers efficiently, and maybe even stop crime before they happen. But is more data always a good thing? In this video, we're exploring why more data isn't necessarily better. It doesn't mean better crime analysis. We'll talk about how big data is used in crime analysis, and then we'll dive into some of the pitfalls, bias, algorithmic bias, visibility bias, and the blind spots that data can't see. Hopefully by the end of this video, we'll have a good understanding of why critical thinking and good old-fashioned analysis still matters, even in the age of big data. So what do we mean by big data? Big data usually refers to extremely large or complex data sets that traditional methods of analysis or traditional methods of investigation struggle to handle. In policing and criminology, this can include anything from years of crime incident reports to real-time feeds from surveillance cameras to social media and phone records. Modern law enforcement agencies are increasingly using big data tools in their daily work for patrol planning, for investigations, crime pattern analysis, trend analysis, and more. And it's really, the appeal is obvious because big data promises more informed decisions, more objectivity, more clear insights. Supporters claim that algorithms can sift through mountains of data, of information, to find hidden patterns that humans might miss. And in many cases, this is true. One popular application is predictive policing. Predictive policing uses algorithms to analyze historical crime data and forecast when and where future crimes are likely to occur. For example, an algorithm might find that certain city blocks, certain parts of a city tend to experience burglaries on a Tuesday evening. So those areas might be flagged for extra police patrols. The idea is to anticipate crime and allocate police resources proactively. In fact, data-driven tools like these have been marketed as ways of making policing more efficient and less biased. Police departments hope that basing decisions on data rather than gut feeling will reduce human bias and errors. Big data analytics are seen as a means to increase efficiency, even accountability. By helping predict and preempt criminal behavior, these tools aim to help police deploy resources more effectively, potentially preventing crimes and lowering crime rates. A practical example is software such as PredPol, short for predictive policing. This analyzes past crime reports to highlight probable hotspots. However, before we get carried away, we need to ask, does having more data automatically lead to better crime analysis? Does it lead to fairer outcomes? We need to question that assumption. Just because an analysis is based on heaps of data, it doesn't mean that it's accurate or just. In fact, without the right checks, big data can be misleading as much as it can enlighten. We're going to look at, in this video, some issues of bias, blind spots, and other pitfalls that can occur, that can hide in this information. The first thing I want to look at is this myth of more data is better equals better insight. There's a saying in data science, garbage in, garbage out. In other words, if your data is flawed, more of it won't help. It'll just give you more flawed results. It's easy to assume that if a little data is good, a lot of data must be great. Quantity doesn't equal quality. Piling up more data can create a false sense of confidence. Think of it this way. If you have a blurry photograph, taking 1,000 more blurry photographs won't suddenly give you a clear picture. You'll just have a mountain of blur. In crime analysis, more data can indeed reveal new patterns, but it can also amplify existing biases or noise. Crime analysts might fall into the trap of believing the numbers without questioning where they came from. The algorithms churning through big data may spot correlations, but correlation isn't causation. And without human insight, we risk misinterpreting what these patterns mean. For example, an algorithm might notice that ice cream sales and crime rates both rise in the summer and conclude that ice cream causes crime. That sounds silly, but it's a reminder that big data can churn out spurious correlations unless we apply that all-important critical thinking. There's also the challenge of overfitting. With enough data, algorithms might find patterns that are really just quirks or randomness in the data. It's a bit like seeing shapes in the clouds. Our tools might detect a pattern that isn't a meaningful signal for the real world. More data can even mean more noise if we're not careful. Without a clear analytical question or structure, analysts can drown in data points and lose sight of the bigger picture. Most importantly, if the data itself is skewed or incomplete, and we'll talk about this in just a moment, then using more of it won't automatically or magically fix the bias. Indeed, it might reinforce it. This is why experts caution that big data can provide a veneer of objectivity that really conceals old problems. We have to be skeptical and discerning. It's not just how much data you have, but what data you're using and how you're using it. With that in mind, let's think about some of the specific types of biases and blind spots that can occur in big data crime analysis. Let's talk about the idea of dirty data in, bias out. The first issue in bias is data collection. Basically, problems in what data gets recorded in the first place. Crime data isn't a perfect mirror of all crime that happens. It's a reflection of human processes like reporting and policing. As a result, the data can be skewed long before any fancy algorithm gets a hold of it. One major problem is that crime data is often incomplete. Not every crime is reported or recorded. In fact, research estimates that a significant chunk of crime goes unreported. Studies state anywhere from 17 to 67% of crimes, depending on the crime type, never make it into official statistics. Think about that. Our databases might be missing a large portion of actual incidents. And missing data isn't random. This ties into something called the dark figure of crime, which we'll explore in a moment. For now, note that certain crimes are systematically underreported. For example, sexual assaults, domestic violence are notorious for being underreported due to victims' fear of shame, and crimes in communities with deep distrust of police also go underreported. So the data we have is often biased towards the crimes that are more likely to be detected and reported. Just think about the consequences for our analysis. But why might a crime go unreported? There's many reasons. We talked about a few just a moment ago. A victim might feel the incident is too minor to involve the police. They might fear retaliation from the offender. If a perpetrator is a family member or a friend, the victim may hesitate to report them. Some victims don't trust the police. Some victims don't want the hassle of a lengthy justice process. Others might not even realize what happened to them was a crime. All these factors create blind spots in our data. We have incidents that have happened but are never entered into the system. They don't enter into our data sets. It's like trying to map a city only using the streets that some people have drawn on the map. Whole neighborhoods might be missing. Even when crimes are reported, the data reflects police activity and priorities as much as it does underlying crime. Police don't patrol every area equally, and they don't enforce every law uniformly. This can lead to sampling bias in the data. For example, if police concentrate patrols in certain neighborhoods, often low-income or minority communities, they will inevitably record more incidents there. Not necessarily because those areas have more crime overall, but because they're under close supervision, close scrutiny, and being watched. Crime statistics often mirror enforcement patterns. A neighborhood with lots of police attention will generate lots of police records, creating an almost self-fulfilling prophecy that the area is high crime. Whereas police may ignore areas that appear safer on paper simply because fewer officers went looking for problems there. Consider this. Consider two neighborhoods in a city, neighborhood A and neighborhood B, that actually have similar experience of, say, minor drug use. If police heavily patrolled neighborhood A, perhaps due to past complaints or misconceptions or preconceptions, they will make many drug possession arrests there. Neighborhood B, with fewer patrols, will have far fewer arrests. The data then shows that neighborhood A has a big drug problem, whereas neighborhood B doesn't. If an algorithm learns from that data, it will predict more crime in A, prompting police to keep focusing on A, creating a feedback loop. This feedback loop was described as the ratchet effect. This can reinforce biased policing patterns. In other words, if the data collection process itself is skewed, then feeding those numbers into the computer won't remove the bias, it will amplify it. And bias in data collection also appears in the form of enforcement priorities. Police departments put a lot of resources into tackling certain offenses and not others. For example, they might crack down on street-level drug offenses and low-level property crimes because those are visible. Residents complain about them, while devoting much less effort to white-collar crimes like financial fraud, often less visible. What's the result? The crime data is rich with information on, say, small-scale drug deals or break-ins, but relatively sparse on embezzlement, corporate crimes, theft. The data can end up being less an objective picture of crime, but rather a mirror reflecting the specific police department or police services priorities. Police might intensify drug arrests around public housing while largely ignoring drug use on college campuses, focusing on petty theft while not scratching the surface of financial fraud. In short, what gets measured is what police pay attention to. All these factors, what citizens report, where police officers patrol, which crimes get priority, they all act like filters on the raw reality of crime. By the time we have our data set, it's already been filtered and skewed by human behavior. This is sometimes called dirty data in the context of predictive policing. If you pour dirty data into an algorithm, you'll get biased results out. We have to acknowledge that these biases exist at the data source level. If we don't, we risk drawing false conclusions. But also, bias can creep in or get worse when we hand our data over to the algorithm. One of the selling points of using algorithms and artificial intelligence and machine learning in crime analysis is that computers don't have the personal prejudices or emotions or biases that humans have. An algorithm isn't racist, it's not biased in the human sense. It'll faithfully follow the rules that we give it, that we program. However, it can still produce biased results. How? Because an algorithm is only as good as its input data and its design. If the algorithm learns from biased data, it will reproduce those biases. Similar to garbage in, we can describe this phenomenon as bias in, bias out. Imagine the algorithm as a student. If you teach the student with flawed examples, it will learn flawed lessons. In policing, we saw that historical data can be biased for all the reasons we discussed. And when the data is used to train predictive models or risk assessment tools, the model essentially inherits the biases present in the data. It might even magnify them, since the algorithm may find statistical patterns that encode bias in subtle or maybe not so subtle ways. Crucially, these biases get cloaked under the veneer of objectivity. The computer printouts, the computer deliverables, they look scientific, they look precise, so people trust them. This can be described as biases being tech-washed, repackaged as impartial numbers. The algorithm's output might appear neutral, but in fact it's reflecting the skewed inputs that went in. Let's unpack a few examples of algorithmic bias in crime analysis. A predictive feedback loop. We touched upon this a little bit earlier. If a predictive policing algorithm is fed past data showing that arrests in neighborhood A are higher than neighborhood B, it will likely predict more crime in A. Police then patrol A more and catch more incidents there, perhaps even further overlooking B. And this cycle continues. The algorithm effectively justifies continuing the same patterns, even if those patterns started due to bias or over-policing. The bias becomes self-reinforcing, perhaps self-fulfilling, but because a computer recommended it, it can be harder to challenge. This bias is hidden behind the complex computer code. Another example is misidentifying high-risk individuals. Some police departments have tried using person-based predictive policing, trying to identify people who might be likely offenders or even victims. An example of this was in Chicago, a now defunct strategic subjects list. This list attempted to score people based on their risk of being involved in shootings. In reality, it turned out to be highly controversial and ineffective. In Los Angeles, in the US, a similar program found serious issues. Data entry was inconsistent and skewed, and half the individuals flagged by the system had few or no ties to violent crimes which it was supposed to predict. In other words, the algorithm was casting a wide net of suspicion on people who weren't meaningfully connected to the targeted crime. Because the system over-relied on arrest records, including minor arrests, it gave some people high-risk scores even if they'd never been involved in serious violence. Police then treated these individuals as likely suspects or potential criminals, essentially punishing them for crimes that they hadn't committed based on a dubious police guess or computer guess. This is algorithmic bias in action. The system's design and input data led to unfair outcomes. Beyond predictive policing, consider tools like facial recognition software, often used to identify suspects from video footage. Studies have shown that some of these AI systems are much less accurate for people with darker skin tones or for women, because the algorithms were trained mostly on images of light-skinned males. The result? Higher false positive rates, individuals being incorrectly matched to suspect photos. That's algorithmic bias stemming from incomplete training data. Likewise, AI text analysis tools have shown similar troubling behavior. One report noted that certain models even classified words like black or women as indicators of negativity or toxicity. Examples outside direct crime prediction, but they illustrate some of the biases that AI has inherited. In a policing context, if such a tool was analyzing social media posts or tips, it might erroneously flag harmless statements or specific communities as dangerous due to these bias. Sometimes the bias is in how the tool is used. We have an over-reliance on flawed technology. For example, a gunshot detection system like ShotSpotter might generate alerts for gunfire sounds. If the system is more frequently installed in certain neighborhoods, you'll get more alerts there. And if the system has false alarms, which audits have found they often do, those neighborhoods may suffer heavier police responses to noises that might not even be gunshots. Likewise, social media monitoring algorithms might flag slang or activism as threats simply because artificial intelligence misinterprets language or the context. These technologies can thus direct police attention in biased or erroneous ways, even if the underlying intention was to be data-driven. The key point is that algorithms are not infallible or inherently fair just because they're based on math. They can perpetuate human biases hidden in data. And unlike a human, who we can be questioned on our reasoning, algorithms often operate as black boxes. It's not always clear to the analysts how they're making decisions. This opacity can make it difficult to challenge the biased outcome. The computer says so, so it must be right. In recent years, more than 1,000 mathematicians and researchers have spoken out against uses of predictive policing algorithms, warning that these systems create a scientific veneer for racism. When the data is drawn from periods of biased policing, any algorithm built on it is standing on a shaky, tainted foundation. So what can be done? Well, for one, there's a push for algorithmic transparency for additional audits. If a police department uses an algorithm, we'd like to know what factors it's considering and to test it for bias. Some jurisdictions have even halted predictive policing programs after community backlash or studies that have questioned their effectiveness. Tech developers have started making tweaks as a way of avoiding sending officers to the same over-policed areas. Attempts to break this feedback loop by occasionally directing patrols to medium-risk areas instead of exclusively sending them to high-risk ones. But these technical fixes only go so far. Ultimately, recognizing algorithmic bias requires vigilance, a little bit of humility, understanding that these systems can make mistakes, and these systems can't replace that all-important human judgment, that critical thinking and decision-making that we have. Now let's talk about visibility bias and blind spots, issues closely related to data collection bias, but worth examining on their own. Visibility bias in criminology refers to the idea that crimes which happen out in the open or areas under heavy watch are more likely to end up in our data, whereas crimes that happen behind closed doors or in marginalized, invisible communities often remain unseen. In short, what is visible gets measured, what is hidden gets ignored. This concept is well illustrated by the dark figure of crime metaphor. Researchers often compare reported crime to a tip of an iceberg. That part of the iceberg above the water, clearly visible, represents the crimes that have been reported to police and that show up in police data, official police data. But the huge mass of ice below the waterline symbolizes all the crime that is unreported or undetected, the dark figure of crime. Just as most of an iceberg lurks out of sight, a great deal of crime never comes to the attention of police, never comes to light. Studies have shown that for some offenses, especially violent and interpersonal crimes, the majority of these crimes are not reported to authorities. Now that's an enormous blind spot for any crime analyst relying on police data alone and certainly working on these crime types. Why do these blind spots matter? Well, if we rely solely on big data analytics without acknowledging them, we'll get a distorted view of reality. For example, an algorithm might conclude that a certain type of crime is rare in a city because there are few police reports. But maybe that crime, let's say sexual assault, is happening frequently. It's just not being reported for the reasons mentioned before. Low numbers in the data could mislead policymakers into thinking that there's not a big problem, where in fact there's a crisis that's lurking under the surface. Again, that dark figure of crime. Similarly, a crime analyst might see that a certain neighborhood has very few reported crime and assume that it's a low crime area. But perhaps that community has such a fraught relationship with law enforcement that residents almost never call the police, meaning that crimes just don't get logged. The reality could be quite different from the official data picture. Same with visibility bias. Crimes that occur in public spaces or in plain view, for instance, a fight on a street corner, open air drug sale, are more likely to be noticed and acted upon by police or reported by citizens. By contrast, crimes that happen in private, like domestic abuse in a home or in the cyber realm, like online fraud, might not be visible at all to law enforcement. Crimes that take place in public are more likely to be detected, while those that don't often aren't recorded. Like I said earlier, people that don't trust the police are less likely to report, even when they've been victims themselves. One major example is communities of immigrants, communities of color, perhaps with historical grievances or challenges with law enforcement. They might underreport crime due to fear of the authorities themselves, or skepticism that reporting these crimes will actually make a difference. Consider this analogy. Think of a fisherman casting a wide net with a certain mesh size. Big fish get caught, smaller fish slip through. If you only count the fish in the net, you might conclude that there's no small fish in those waters. But that's because your net wasn't catching them, not because they don't exist. In crime data, our nets, our police methods and reporting systems, catch certain incidents and miss others. Underreported crime, underpoliced areas, overlooked offences are all the ones slipping through the net. A striking example of a blind spot is crime among communities that handle things internally. In some communities, there may be an alternative community mechanism, or simply a norm of not involving the police. Let's say if two youth from the same community get into a fight and resolve it informally, it won't show up in assault statistics. If a local business repeatedly experiences minor theft but never reports it, those thefts don't appear in the record. On the other hand, more visible crimes like a loud burglary that prompts a neighbor to call 911, that will enter the data. The result, an uneven landscape of data that might say more about visibility and trust rather than actual crime rates. Another example is the enforcement disparity between different social spheres. White-collar crime is a classic blind spot when it comes to crime analysis. It's vastly underreported, underdetected relative to the harm that it causes. Complex financial crime or corporate offenses often require extensive investigation to uncover. So if resources aren't dedicated to it, the official crime data will show very low instances of these crimes. The police and the algorithms might then ignore white-collar crime because the data doesn't flag it as significant, even though its economic and social toll can be enormous. It's under the waterline of our iceberg. So, how do we handle visibility bias and blind spots? Well, the very first thing is to recognize that they exist. Criminologists and crime professionals use methods like victimization surveys, such as in the US, the National Crime Victimization Survey, to try and get at some of that dark figure of crime by asking people about their own experiences, whether or not they reported them. These surveys often reveal much higher rates of certain crimes than police data, confirming the dark figure of crime, the iceberg analogy. For an analyst, awareness is key. Always ask, what might I not be seeing in this data set? Perhaps there's some supplementary data that we can add to highlight. Maybe there's some community surveys. Maybe there's some other external information that can clarify. It's also important to understand that big data doesn't automatically capture hidden data. High volume doesn't mean high completeness. We can have terabytes of police records, years of police records, and still be missing whole segments of reality. In fact, if those terabytes are all from the same biased processes, they might collectively share the same blind spots. An algorithm won't magically fill in the blanks of unreported crime. It can't predict what it's never been given to learn from. Crimes not reported or investigated by police do not become data points for future forecasts. That's a fancy way of saying if it's not about the data, the computer has no clue about it. This is why an over-reliance on data can be dangerous. We might become blind to what the data doesn't show us. We've identified a lot of ways that big data and algorithms can lead us astray. Biased input data, feedback loops, invisible crime, etc. But this brings us to this kind of crucial takeaway. No matter how advanced our data systems get, human judgment and critical thinking are still indispensable in crime analysis, indispensable skills for analysts. We can't just feed all the information into a machine and accept whatever comes out as truth. We need analysts, criminologists, police officers with community knowledge to interpret and question the results, give them context. For one, humans are needed to spot when something doesn't smell right in the data. An experienced analyst, for example, might notice that an algorithm is disproportionately flagging people from a certain neighborhood and ask, are we sure this isn't just because of heavier policing there? A computer won't ask that on its own. A computer will blindly trust the input. A critical human mind can inject context into that argument that the data lacks. Like knowing, for example, that many domestic violence cases go unreported. So perhaps we shouldn't conclude that domestic violence is low in our city based on the fact that there are low police records. Critical thinking also helps in formulating the right questions in the first place. Big data can crunch numbers, but deciding what to look for and how to use results ethically is a human decision. Should we use an algorithm to predict who might commit a crime? Well, that's as much an ethical question as a legal question as a technical question. Just because we can analyze something doesn't mean that we should do so blindly. Human analysts and community stakeholders should guide how these tools are deployed, ensuring buy-in, enhancing fairness and effectiveness, not undermining them. Another reason the human element remains vital. The algorithms themselves, they lack common sense and moral judgment. They might identify a suspicious pattern that a human would immediately recognize as a benign situation. For example, if a predictive system notices a person has several associates with criminal records, it might flag them as high risk. A human officer or social worker who knows the community might counter, actually those are family members, and that living in that environment is unavoidable and this person actually isn't involved in their activities. Without a human check, the system might unjustly label someone. We must remember that crime patterns emerge from social contexts, and humans are better at understanding context than computers. Well, at least for now. There have been many real-world cautions on this. A report from the Brennan Center, for example, noted that police officers who rely too heavily on AI systems might become overconfident in the computer's conclusions, might even overlook or ignore facts that contradict the algorithm's determination. In other words, if a computer says that suspect X is hiding in location Y, police might dismiss evidence that points elsewhere. An example of tunnel vision, confirmation bias. It's the modern equivalent of having blind faith in a map. You might drive into a lake because your GPS insists there was a road. Critical thinking is our safety check. It's our common sense filter. It's looking out the window and asking the question, does this make sense? Moreover, structured human analysis brings in methodologies and techniques that data alone might not. Criminologists use theories about why crime happens, such as social disorganization theory, strain theory, rational choice theory, to interpret patterns. Big data might tell us where and when crime clusters, but understanding why, that's on us. That's a human endeavor. Two neighborhoods could have similar crime spikes for very different reasons. One might be to gang conflicts, one might be to an economic downturn. An algorithm treats them the same, but a human analyst investigating deeper could suggest very different reasons and also suggest very different interventions for each case. This is where structured analysis comes in. It's not just free-form thinking, it's applying frameworks and careful reasoning to the data. For example, an analyst might use the SARA model: scan, analyze, respond, assess, from problem-oriented policing to systematically break down a crime problem. Big data can aid certainly in the scan and analyze steps, but coming up with a tailored response and later assessing it requires human strategy and evaluation. Finally, let's talk about accountability and ethics. Algorithms don't take responsibility, people do. If a data-driven decision leads to a tragedy or an injustice, say a wrongful arrest or an underserved community being neglected, we can't simply blame the computer. Humans must remain in the loop to ensure decisions are fair and justified. Keeping critical thinking at the forefront also means continually questioning the systems. Are these systems actually effective? Are they making things better? Or are they just giving the illusion of high-tech progress? It takes human oversight to perform these tasks. In fact, some police departments, after experimenting with predictive policing, have rolled back those programs due to concerns about efficacy and bias. These course corrections, these rollbacks happen because people scrutinize the outcomes, not because the data self-corrected. Again, human intervention. As a rule of thumb, we should treat big data and algorithms as tools, albeit very powerful ones, but not as oracles. They can augment human decision-making, but they shouldn't replace it. A hammer is great for building a house, but you still need an architect and a builder. The hammer doesn't decide what the house should look like. The architect does. Similarly, data can provide insights, but humans must decide what to do with those in a thoughtful manner. So let's conclude. Let's look at some of the key points that we've talked about in this video. Big data has enormous potential in crime analysis. If used properly, it can identify hotspots, it can identify patterns and trends and help us allocate resources in ways that were impossible in the past. However, more data doesn't automatically guarantee better insight or fairness. We have to be mindful of bias in how the data was collected, who or what gets counted. We need to be aware of algorithmic bias, how analysis can perpetuate prejudice, and conscious of visibility bias, conscious of blind spots, what data is missing. Crime data can paint an incomplete picture, but without critical thinking, we might confidently draw the wrong conclusions from that picture. The promise of big data that it presents to criminal justice and policing is exciting. A lot of new technologies coming out every day. But it must be approached with caution, a little bit of humility. We need to continuously ask what biases might be hiding in these numbers, what stories, what incidents are not being told by this data. In the age of AI, in the age of analytics, it's more important than ever that our human ability to question and contextualize is practiced. Ultimately, big data should be seen as an aid, not a shortcut. As one ACLU report wisely noted, we must collect and use data with an eye towards rooting out inequalities and injustice, not inadvertently cementing them or reinforcing them. That means shining lights on biases and blind spots, means demanding transparency in our fancy new algorithms. It also means sometimes saying that the data might suggest X, but given the context, the right action is Y. Critical thinking acts as the compass that keeps us orientated, keeps us focused, keeps us effective, prevents us from getting lost in the big data. The next time someone claims that predictive policing or big data analysis is a magic bullet that's going to solve all the issues, we know what questions to ask. More data can be powerful, but only if we use it wisely and carefully. Insight doesn't come from data alone, it comes from the making sense of the data by humans. And that making sense is profoundly something that we as humans can do. We shouldn't just collect more data, we should cultivate more understanding, more context. If we trust data without discernment, we risk becoming blind to all those biases. If the goal is safer, fairer policing, it requires blending the best of technology with insights, with human context.